Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video. And today's video is about another interesting concept in the subject electrical and electronics engineering. And today we are going to see another problem in mesh analysis. And also I'm going to explain you how to use calculator to solve the expressions, right? And we will start with one particular problem where I'll explain the procedure and then I'll explain you how to use calculator to solve the equations, right? So this is the problem which we are going to see, right? So if you look at the question, they have asked you to apply KVL, right? And find out the current in each resistor. So we have to find out the current in each resistor. I have already explained you the procedure to be followed for mesh analysis in previous video. I would recommend you people to go through that video first so that you can understand what is the basics about mesh analysis, what are the rules that we're going to follow, so that you can easily understand this particular problem, right? So if this question is given, first thing what we're going to do is we're going to consider the current across all these meshes is in the same direction. So I consider I1 and I2 in same direction. So if you're going to consider I1, I2 same direction, and then what we have to do is we have to put plus, minus, plus, minus. Whenever you're approaching any resistor, it is plus, and while leaving, it is minus. And then you have to write the equation. How will I write the equation? Now I consider this mesh. This mesh is B, C, F, and A and B, right? This mesh B, C, F, A, B. So we're going to consider this. Now I want to start from here, right? So it is 5 I1, 5 I1. That is the current flowing here, right? And again it is plus. So plus 2. And here you have both I1 and I2. So how will you write? I already said you have to consider, always assume I1 is greater than I2. So you will consider I1 minus I2, right? And here it is minus. So you write minus 10 is equal to 0, right? So now you simplify this one. 5 I1 plus 2 I1 minus 2 I2 minus 10 equal to 0, right? So how will you write this expression? Now it is 7I minus 2 I2 that is equal to 10. This is equation number 1. This is equation number 1, right? And now you see this expression. Say second mesh. Second mesh is C, D, E, and F. F and C. And now in this mesh, right, what you're going to do, we're going to write the expression. So it's going to start from this particular resistor. It's 10 I2, 10 I2 plus 50. We're approaching plus here, right? So it is plus 50. And here you're approaching minus, right? So it's minus 2 I1 minus I2. That is equal to 0, right? So now how do you write this expression? It's 10 I2, right? So it's 10 I2, right? And now it's minus 2 I1 plus 2 I2 is equal to minus 50, which means it is minus 2 I1 plus 12 I2 is equal to minus 50. This is expression 2. This is expression 2, correct? Now we'll see whether we got the correct expression. So you can see this 7I1, 2I2 is equal to 10. 7I1, 2I2 is equal to 10 minus, right? So you can see we got the same expression. And similarly here, it's minus 2I1 plus 12I2 minus 50. Minus 2I1 plus 12I2 minus 50. Okay. So it's the same procedure we're going to follow, right? So I'm going to start from this particular mesh, right? So it is plus. So I'm putting plus 5i1. So it is plus 2. So it's plus 2i1 minus i2. And again, I'm approaching minus here. So minus 10. Similarly, this mesh, I'm going to consider this one. So it's 10i2 plus 50 because I'm approaching plus, and it's minus here. When I approach from here, it's minus I1 minus I2. Don't get confused with plus and minus. First, when you assign the values of plus and minus for resistor, go with that. Then you have to just see whether you're approaching plus or minus. If you're approaching plus, put plus. If you're approaching minus, put minus. So now you got this two expression, and you can solve this expression mathematically, manually, or you can use calculator, right? So you can use calculator. Most preferably, this calculator is preferred because in exams, the advanced calculators, programmable calculators are not allowed, right? So if you solve this expression, you will get I1 is equal to 0.25 and I2 is equal to minus 4.125, right? And again, what to understand here, to be frank, we are considering all the meshes in the same direction, right? And that is why we are getting minus sign here. But actually, this is, if you see this mesh, like the voltage flows from this direction, right? But for simplicity, we are taking it the other direction, right? So here, when you get minus, you neglect that minus, and you mention I2 as 4.125 in any problem, right? Because we're going to follow the same procedure, so you will remove this minus, right? And now you need to find out the current that is flowing across all the resistors. Now you find out I1 and I2, right? So this current I1 is flowing across this 5 ohm, and this I2 current is flowing across this 10. But whereas if you take 2 ohm, it has both I1 and I2. So what do you have to do? We have to find out the current that is flowing through 2 ohm, right? You can uh, you can do it in either way. That is, if you're going to consider the minus sign, you can consider I1 minus I2. I1 minus I2. If you're going to have this minus again, minus with minus, right? Without neglecting, what you can do is you can put I1 minus I2, which means it will be 0.25 minus of minus 4.125, which will become plus, right? So you'll add 0.25 plus 4.125, right? You can also do that way. Or if you're neglecting that, you have to do, you are neglecting this minus and you are writing as I2, then you have to write as I1 plus I2. I1 plus I2, that is actually correct. Whereas while writing the answer, right, the solution, at last you will write like this, right? So current, the voltage from here, it will flow like this way, and here it will flow this way. So the current here at I2, it will be in the same direction. I1 and I2 is flowing in the same direction. So it is I1 plus I2, right? I1 plus I2. So you have already find out what is I1, what is I2, right? And you're going to add this one and you will find out 4.375. So the current across 5 ohm is 0.25 and current across R 10 ohm is 4.125 because it is only I1 here and it is only I2 here, whereas here it's I1 plus I2, right? Clear? Right, now I'll explain you how to solve this expression equations using calculator, right? So you see, for calculator, what you have to do is, first thing you have to select the modes, right? So you have to select the equation mode. You have to select the equation mode. So for that, you have to press mode. First, if you press mode, you'll get this screen. And if you press mode second time, you'll get this screen. And the third time, if you press, you'll get this screen. Where from this screen, you have to select one, and you'll get the expression. You'll get the screen like this: 2 or 3 unknowns. Here we have to find out I1 and I2, only two unknowns. So you will select number 2. So then after selecting 2, it will ask you the values. It will ask you A1. I'll tell you what is A1. You can see here from our expression, A1 is 7, B1 is minus 2, C is 10, right? And similarly, A2 is minus 2, right? And B2 is 12 and C2 is minus 50. That is the value I'm giving here. So you can see here A1 I'm giving it as 7 and for B1 I'm giving it as minus 2. You just press equal, it will ask again next values, right? So and then C1 I press 10 and for A2 I'm giving minus 2, right? And similarly B2 I'm giving it as 12 and C2 I'm giving it as minus 50, right? And after giving uh, C2, that is A1 B1 C1 and A2 B2 C2. If you press equal, you will get the first expression, that is I1 is 0.25 and you can see I2 is minus 4.125, which we obtained the same expression, right? And after this, you will find out the current for all the resistors, right? So you can use calculator, right, to solve the expressions. Depending upon the marks, you decide whether you got to use calculator and you can simplify the expression, or else you put manual calculation and verify the result with the calculator, right? So today what we have seen is we have seen a problem for mesh analysis. I believe this video will be useful for you. Thank you, my dear students.